Here's a question 2 difficulty level on an AMC 8. Suppose we have a Lego set for building a stormtrooper. Stormtrooper is from the Star Wars movie. Star Wars is a movie where there's a lot of black and white. Darth Vader is all black, and stormtroopers are all white. I actually saw a joke lately that said somebody thought of asking for making a coloring book for stormtroopers and Darth Vader. You would be done with the coloring already. And that's actually why I chose this, because this question is a question with only 2 colors, black and white. Because if you're building the Lego set, you have 2 colors for your pieces. And this Lego set has only black and white Legos. Suppose that there are, for every 7 black Legos, there are 13 white Legos. Suppose that there are 91 black Legos altogether. Then how many white Legos are there? Well, this is a question about ratios and proportions. The only thing you need to be careful about is to make sure you read the question carefully. So it says there are 91 black, and here's 7 black, 13 white. So what I'll write is that for every, let's write the columns, black and white, what we have in the problem says that for every 7 black, you have 13 white. I want to share with you that sometimes the way that people will write this is they will write 7:13. I want to let you know that in case you ever see this written somewhere, possibly on an AMC problem. Well, if it's 7 to 13, and now the problem says that you have 91 black Legos, there are many ways to finish at this point. And here I will just say one of the quick ways is to just say from the 7 to the 91, what do I need to multiply by? Well, that means that I need to know what is 91 divided by 7. If you do that, if you take 91 divided by 7, let's just do it quickly on the side. If I take 91 divided by 7, 7 times 1 is 7, 21, 3. How nice. It actually divides cleanly. 7 times 13 is 91. So these numbers were chosen carefully. If that's times 13, this one here should also be times 13. And so I get that 13 times 13, well, I now need to multiply those numbers together. Let's do this. Let's do this over here. 13 times 13, 339, 339. By the way, as I'm doing this, I'm also reviewing some of the common number multiplications. 13 times 3, 39. And then here, once you're used to those, these are all tricks now, how to speed up, actually. You can put that 13 down, add together 169. I chose that number carefully, because 169 is also an important number to remember. That is 13 squared. OK. And so what this tells you is that the answer to the problem then is that if it was 7 black to 13 white, then if there are 91 black, there are 169 white. And then you would be done. Let me share the kinds of things you want to do on this question to make sure you don't make a mistake. You see, on this question, the most easy way to make a mistake is to read it wrong. And so that's a tip I want to give. If you see a problem like this, even if you do it twice, you should also make sure to read it twice. Because this 91 is very dangerous. If you had misread the problem and thought there were 91 white Legos, actually you would still get a nice answer. Because if you did this wrong, and you pretended that it wasn't this, but if you pretended that this was the 91, then you'd have said that 13 times 7 gives you the 91, and you'd get 7 times 7 over here to get 49. And you would have concluded that there are 49 as the answer. You see, the reason why this is the case, and this is wrong, by the way, the reason why this is the case is actually because the 91 that I chose is a very special number that I also want to introduce to you. 91 is one of the smallest numbers that people accidentally think is prime. I say that because when you think about whether a number is prime, the first things you check are, is it even? No. Is it a multiple of 3? There's a rule for multiple of 3, adding up the digits together, seeing if it's a multiple of 3. No. And is it a multiple of 5? Well, also no, because it doesn't end in a 0 or a 5. And then we don't have a nice rule for checking multiple of 7. So I chose this to introduce to you that whenever you see 91, remember, 91 is actually 7 times 13. It factors that way. Okay. But I also wanted to use this problem to introduce to you the number 169, which is also very important for 2 reasons. The first reason is because 169 is beyond what most people memorize in their multiplication table. You might memorize up to 10 times 10. You might memorize up to 12 times 12. 13 times 13 is 169. Why is that important? Actually, also because of geometry. I will share with you that there is a very important triangle, which comes if I take a right angle and I put one side here 5 and one side here 12. This Pythagorean theorem now tells me that the length of this side here is the square root of 5 squared, which is 25, plus 12 squared, which is 144. And most people will be quite familiar with 12 squared, 144. If you add those 2 numbers together, 144 plus 25, then that gives you 9, 6, and 1. And so this 169, square root of 169, we now know is 13. And so I wanted to introduce this 169 to you because if you come across any triangle like this, and then you see this 169, you will know that the square root of that is another whole number. And so you have this 5, 12, 13 right triangle. And so the idea is this particular problem includes in it a bunch of carefully chosen numbers, 91, 169. And also I want to share the tip on this question, is that when you do it, since it's so quick, read the question one more time at the end, and then you will make sure that you had it